I'm prime, Prime. Only factors are 1 and me. Factors that divide evenly. 2, 3, 5, 7, 11.
Hi 6th graders, Mrs. Fleming here. Tonight's our third lesson, 6.3, on prime factorization. We have 3 objectives tonight. The first one is to recognize primes and composites, to use a factor tree to find prime factors, and lastly, find prime factorization of numbers. First thing we'll do is enter prime number into your key points, part of your Cornell notes. A prime number is a natural number like the counting numbers 1, 2, 3, etc. That is exactly divisible by 2 natural numbers. And those natural numbers happen to be itself and 1. So earlier today we put a number chart into your math notebook, and we're going to use that chart now to identify the prime numbers. First, we want to note that 0 is not a prime number, so we'll cross that one off. And 1 is not a prime number either. Although 1 is divisible by itself and it's divisible by 1, those aren't 2 other natural numbers. So therefore, 1 cannot be prime. So the next number to test would be 2. So when we think of the number 2, we know that the factors for 2 are 1, and it could be divisible by itself. No other natural numbers can divide 2, so therefore 2 is prime. So what's special about 2 is that it's the only even number that is prime. Therefore, all the other even numbers on our chart are not prime because 2 is a factor of that even number. Therefore, all even numbers are not prime because they are divisible by more than 2 natural numbers. So I'd like you to pause the video and have you X off all of the even numbers on your chart. Press play when you've finished. So you can see we eliminated quite a few numbers from our prime number chart because a lot of numbers are divisible by 2, all even ones. The next number on our chart is 3, and 3 is also prime because it is only divisible by 1 and itself. It's not divisible by 2. It's not evenly divisible by 2. So therefore, 3 is prime. And now what I'd like you to do is to go through your chart and identify other numbers that are divisible by 3, and therefore they're composite. They would not be prime because one of its factors would be 3. Remember to use your rule of divisibility for 3. Add those digits together, and if it's divisible by 3, you'll cross it off. Press play when you're ready to check your chart. Did you catch all of those? Take a close look at the chart. 39 isn't prime. Even though both digits are odd, that's one of those surprising ones. Same with 51. So by adding those digits together, we identify that 3 is a factor of those digits. Next, we would test for 4. And 4 has the factors of 1 and 4, but it also has the factor of 2. So therefore, 4 isn't prime. Next to test is 5. And 5 is divisible by itself, of course, and by 1, and no other natural numbers. Now what I'd like you to do is go through your chart and cross off any numbers where 5 is a factor. When you're ready to check your answers, press play. You may have noticed that several of the factors were already crossed off, like all the multiples of 10 and several of the 5 because they added up to a number that was divisible by 3. We don't need to test for factors of 6 because we've already crossed off any numbers that were divisible by 2 and 3. Remember from our rules of divisibility chart, that takes care of that. 7 is prime because it's only divisible by 1 in itself. What I'd like you to do next is cross off any numbers on our chart that have 7 as a factor, because of course then they're composite. When you're ready to check your work, press play. A couple of surprises on the chart, like 91. Next, we would cross off any numbers where 11 is a factor, and we can already identify that we've crossed off all of the multiples of 11. So the numbers that we had left on our chart that weren't crossed off are all prime numbers. So the digits that I highlighted represent prime numbers. It's important to identify the prime numbers because we're going to be using them in our next portion of our lesson. Oops, sixth graders made a huge mistake back there. 5 is prime. Adjust your chart as necessary, then press play when you're ready to continue. The next objective of our lesson is to use a factor tree to find the prime factorization of a number. So what that means is we want to break down, like the number 75, into prime numbers. So to do that, I've already made a list just to remind us of the first few numbers. 2, 3, 5, 7, and 11 are prime. 4, 6, 8, 9, 10, and 12 are not prime. So to find the prime factorization of 75, we want to start with our prime numbers. So we want to think about 2 first, and is 75 divisible by 2? Nope, it's not even. So next we try 3. And 3 is, because if you think about money, there's 3/4 in 75 cents. So therefore, 3 times 25 is 75. We're looking at the number 25 then, because 3 is already prime. Looking at 25, we want to again go back to our prime numbers, and 25 would not be divisible by 2 because it's not even, and 75 wasn't divisible by 2, so that wouldn't work. We know 3 is not a factor of 25, so the next prime to check is 5. So we know that 5 times 5 is 25. The prime factorization of 75 is 3 times 5 times 5. Now it's your turn. Find the prime factorization of each number below. Press play when you're ready to check your work. You may have used different factor pairs, but the prime factorization of each number will still be the same regardless of which combination of numbers you may have used. So therefore the prime factorization of 100, say, is 2 times 2 times 5 times 5, even though you may have done 10 times 10 as the first factor pair in your factorization tree. I happen to use the method I mentioned in the earlier screen about starting with the lowest prime and working your way up. Let's do a little more practice, and when you're ready to check your work, press play. Think about using that prime factorization strategy of starting with 2 and then 3, or you can use rules of divisibility and find the primes, and then write the prime factorization for each number. Press play when you're ready to check your work. Be sure to look over any of the answers that you may have had errors on and make corrections. So tonight's lesson, 6.3, was on prime factorization. Our objectives were to recognize primes and composites, use a factor tree to find prime factors, and then find the prime factorization of numbers. Review any part of this lesson you wish, then head on over to Schoology.com and take the quiz. See you tomorrow.